Number 6, we have another elevator problem. So let's start by drawing our free body diagram. We've got the person here, got a normal force on the person going upward, and that's what the scale reading is going to be, is that normal force. That's the apparent weight. Then we have the weight going down, and the trick is to figure out which way is the acceleration. We're moving upward, but we're slowing down. We learned that if you're slowing down, that means your acceleration goes opposite your velocity. So we were moving upward, but our acceleration must be going downward if we're slowing down. So that was the trick, is really just figuring out the free body diagram and which way the acceleration is. And then you know from experience that if you're accelerating downward, that you feel lighter. So the scale reading would be less than 700 newtons. But you can still do it by writing the equations again. Use Newton's second law, the sum of the forces equal to ma. The weight, mg, minus the normal force equals ma. I'm using down to be positive here. And then you solve for the normal force. You're going to get normal force equals mg minus ma. So you do appear to be lighter than your real weight. Really, the trick to these problems is to make sure that you see which way the acceleration is so that you can set it up correctly. Number 7, so for this one, all we have to do is use the definition of weight, which is mg, and if we weigh 99 newtons on the moon, then we can figure out our mass on the moon is going to be our weight divided by g. It's going to be 99 divided by 9.8. And then we want, oh, I'm sorry about that, 99 divided by 1.62. And then we want to find out the weight on the Earth. So weight on the Earth is mg again, but now we're going to use the mass that we just found over here, and now we're going to multiply that mass by 9.8, and that will give us the weight on the moon, which should be about, the weight on the Earth, which should be about 600. So takeaway message from this one is really pay attention to the units. If you're given something in newtons, then you know that you're given the weight, and you can get the mass from there by dividing by g. If you're given something in kilograms, then you're given the mass. And then sometimes you have to multiply the mass by g to get the weight. Let's do one more. So this one is one that goes back to the test 1 material, just to make sure that you still know how to use your kinematic equations. So let's write down our givens. We have VI right here. Slows down is 27 meters per second. Slowing down comes to a stop. That means VF is 0. And that's the distance traveled is 578 meters. And what was the force that allowed this to happen? So what we need to solve for is the acceleration. And a kinematic equation that has those 4 variables in there is this one right here. So we just take this kinematic equation, solve for acceleration. V final is 0. So acceleration is going to be negative V initial squared divided by 2 times delta x. And then we know that the force that produced this acceleration is going to be equal to m times a. So plug in the mass here, which was the 1100 kilograms, times the acceleration that you found here, and you should get 690 newtons.